Hello all. Our project title is Experimental Investigations on Polypropylene Fiber Reinforced Concrete. The team members are myself, Geeta and Nagamal. Our project guide is Ms. D. Anjala, Assistant Professor. The aim is to study the strength and flexural behavior of the polypropylene fiber reinforced concrete by using polypropylene fiber. Here polypropylene fibers are added in different ratios such as 0.5, 1, 1.5 and 2%, and various tests has been conducted. Here M40 grade of concrete is being adopted. The mixed design is done based on codebook IS 10262-2009. Specimens are first casted and cured for 28 days, and then after they are tested, and we came to a conclusion that 1.5% fiber showed maximum results. Concrete is good in compression and steel is good in tension. Addition of this fiber improves the post-peak ductility performance, flexural strength. This is the polypropylene fiber we are using, manufactured by Reliance India Private Limited, India Limited, in the brand name Recron 3S. These are the material details for polypropylene fiber, super plasticizer and cement. Coming to literature review 1 is titled as Polypropylene Fiber Reinforced Concrete. A review. The results are: the flexural strength of the first crack is a fiber content increased from 1%. The ultimate shear increased up to 5%. The results is that the low tensile strength of concrete has been overcome. Literature review 2 is titled as Strength Properties of Polypropylene Fiber Reinforced Concrete. The results are compression strength and flexural split tensile strength increased up to 1.5% fiber content. They have came to a conclusion that the increase in compression strength was 34, while that of the tensile strength is 40. Literature review 3 is Behavioral Study of Steel Fiber and Polypropylene Fiber Reinforced Concrete. Here two types of steel fiber is used and one type of polypropylene fiber is used. It is concluded that high split tensile strength is achieved at 0.5% of polypropylene fiber. Literature review 4 is titled as A Study of Properties of Polypropylene Fiber Reinforced Concrete. The results are: addition of polypropylene fibers at lower values like 0.18 to 0.40 increases its compressive strength by 5%. Shrinkage crack is reduced. Literature review 5 is titled as Comparative Study of Polypropylene Fiber Reinforced Concrete with Conventional Pavement Design. The results are: the maximum flexural strength was at 2% of fiber. Compression strength increases with increase in percentage of polypropylene fiber. Literature review 6, a comparative study of basalt and polypropylene fiber reinforced concrete on compressive and tensile behavior. The results are: low percentage of fiber increases the tensile strength up to 5.6% respectively. This is the methodology. First we have collected and studied the journal, and then we have collected the fiber, followed by various tests, and then mixed design, casting, curing, and then testing of specimens, that is compressive, split tensile and flexural, and finally results and conclusion. This fiber, polypropylene fiber reinforced concrete, reduces the appearance of crack at initial stage. Test conducted for cement or specific gravity by Lee-Chatela's apparatus and fineness of cement. These are the corresponding values. Test conducted for fine aggregate is the same: specific gravity, fineness modulus, and then water absorption. The values are here. Test conducted for coarse aggregate are specific gravity, aggregate impact, crushing test, and water absorption. These are the mixed design. Well, coming to mixed design, grade of concrete is M40, type of cement is OPC 53 grade. 20 mm is the maximum nominal size of aggregate. Water cement ratio is 0.45. Workability is 100 mm. These are the test material data required for the material. At first we have to calculate the target mean strength. FCK dash is equal to FCK plus 1.65 S. S is the value of standard deviation. Then water cement ratio is being selected from table IS 456 2009. Maximum water cement ratio is taken as 0.45. We have adopted 0.40 as water content, water cement ratio, then it's water content, then it is cement content. followed by proportion of volume of coarse aggregate and fine aggregate content. Finally, after achieving the volume of all aggregates, we have moved into mix calculation. These mix calculations have been done for per meter cube. Volume of coarse aggregate, two types of coarse aggregate has been used, 20 mm and 12.5 mm in order to fill the pores inside the concrete mixture. And finally the mix proportion. The mix ratio has been achieved as 1:2.1:3.4. These are the proportions of materials that are required to cast the cube specimens. These are the proportion of materials required to cast the cylinder specimens. These are the proportions required to cast the beam specimens. Next, cast curing of specimens. These are specimens before curing and after curing, that is after 28 days. Testing of specimen, compressive strength test. These are the picture shows before testing and after testing. Split tensile strength test, cylinder before testing and after testing. The specimen kept for flexural test, strength test. Results and discussion. First, compressive strength. From the graph, it is shown that 1.5% showed maximum result and after 2% it is gradually decreasing. The strength is gradually decreasing. Number 2, split tensile strength. The graph is plotted against split tensile strength and fiber volume ratios. 1.5% shows maximum strength, whereas 2% the strength is gradually decreased. Number 3, flexural strength. 1.5 ratio shows the maximum strength and as usual 2% it is gradually decreasing, shown in the graph. Well, coming to conclusion, specimens are casted and after 24 hours they are being demolded and cured for 28 days. Potable water is being used for concreting and curing of specimen. Water cement ratio 0.40. The samples with fiber contents of 1.5 showed maximum results, and these are the references we are used here. Thank you for watching the video.